So this is BeatCutter, a new app from Igor Vasiliev for, well, what is it for? It's not immediately obvious. I see this as a kind of a spiritual successor to his other apps, Fieldscaper and Soundscaper. So like those apps, BeatCutter lets you take a bunch of sounds and mangle them in interesting ways, but here the focus is more on how you can chop the sounds up and recombine the pieces. In Fieldscaper and Soundscaper you could work with layering up to 3 independently mangled sound sources. With BeatCutter you can work with up to 8 independent sound sources, but the innovative part is how these sources are dissected and spliced together rather than simply overlaid. Now, to understand the power of this you really need to understand BeatCutter's front page, which is this rather striking and complicated, fiendishly complicated looking matrix, because that's the key to how BeatCutter works with the sounds systematically. Now that's a point that's worth repeating. You might think that a lot of this app is about randomization, and particularly as the randomize function on the templates page, I'll just show you that, gets, here it is at the bottom, gets a lot of attention, but in fact the splicing and recombining is highly systematic, and this can lead to unexpected and we hope interesting patterns emerging rather than just cacophony, although there's a lot of potential for cacophony as well, as you'll probably see. So I'm going to focus in this video on the matrix and how it relates to various other parts of the app. By the way, just having mentioned the templates page, which is this one here, I suggest that you ignore that at first. You can explore the entire app avoiding this page completely, well, with one exception. What you have to do is, and what we will do is, we'll put this very first number on the left to, well, in this case 8, which is the number of sound sources we're going to use. Can't see any other way to do that. But beyond that you can absolutely ignore everything else on this page, because it's not necessary. As far as I can tell, the templates are just some super nerdy way of setting up all the other parameters from one place. Perhaps it doesn't help that the quick start guide in the manual goes straight to the templates page, which I don't think it does the app any favours. So we're gonna ignore that. So let's start with kind of a thumbnail sketch of what this app does. On the front page we have this matrix, which at its heart is an 8x8 array of cells, and each of these cells can contain a snippet of sound. So when BeatCutter is running, so that's when this start button down at the bottom right is activated, something is continually stuffing sound snippets into those cells, while something else is continually scanning the matrix and pulling out sound snippets to send to the output. And these two processes run, as I say, in parallel and are entirely independent. Of course there's a lot of other things happening as well, as you might guess, which we'll get to in due course. So let's start by looking at how the sounds get stuffed into the cells. Now BeatCutter uses the term recording to refer to this, and the sounds are recorded from one of 8 possible inputs. Now on the front page these inputs are visualized by these blue circles, which in this configuration are shown down at the bottom. There's also this outer blue ring which I can make highlighted if I click the appropriate thing. We'll get to that in a second. Well, in fact let's just leave it highlighted for now. Now if you look carefully you'll see that each of these numbered blobs, numbered 1 to 8, has a line that extends through some of the cells in the matrix. If we just look at number 1 here, if we stop that, let's try reloading that. The problem is once this is running you can't stop it and clear the grid. That's something that's I guess a missing feature. What you have to wait for is for all those sounds to, well, it kind of decays away over time as all the sounds get played. That's jumping ahead. So back to the plot. If you look carefully you'll see that each of these blobs, these blue blobs numbered 1 to 8, denoting the inputs, has a line that extends, in this case upwards, through a bunch of cells. In BeatCutter terms, this is a bus, or an input bus in this case. Now a bus is nothing more than a line connecting 8 cells in the matrix, and its significance is that it unites those particular 8 cells in some sense. Now the specifics of that depend on the circumstances and on what kind of bus it is. Now that line is just happens to be easier to see when the bus is active because it lights up. You can see in this case input bus number 5 seems to be flickering on and off, and when it's off it's kind of dim, so you can't see it very well. So let's have a quick detour to see how a sound source gets linked to an input bus, and we do that by going to the input tab, which is at the top of the screen here. These are like, well, I say tab, this is kind of like a tabbed dialog. If I just flip through these, you can see we go to different pages, and main is the one with that's what I'm calling the front page, the one with the matrix on. If we go to INP, this is a page where we configure the input sources for all of the buses. Now we select each of those 8 independent input buses by clicking these things along the bottom. So you can see for input bus 1, 2, 3, 4, something's changing, and then the most notable thing that's changing is this waveform we got along the top. Now there's 2 ways you can feed inputs, sound inputs, to this application. The simplest way, and the way that we're going to use for this entire demonstration, is to use input files. Now to do that, for this particular input bus, you need to make sure that over at the left hand side here we have the button labelled file at the bottom clicked. You can have something else clicked. This C1, C2, C3 and C4, those allow you to use live inputs, which are piped in from a host app such as AUM. But for now we're going to just use input files. Now they're all set up, these buses are set up to different input files. There is well, let's just, to load a file, you go up to the top left here, you'd click this file button, and now when you first run this app you won't see anything here. You have to click the import button, which takes you to the files dialog, lets you suck things in from elsewhere on your iPad. But I've imported a whole bunch. You select one here and then click set. I've already done that. Now as far as I can tell, there's no obvious way to preview that input from this screen. There is a way to do it from one of the other screens. I'm not going to show you that now because it will just confuse things. We'll get to that. So anyway, as you can see, I've got all 8 input buses, trying to get used to the terminology here, are populated with audio files. Back to the matrix. And so this is running, it's silent at the moment, I've got it muted because it's getting in the way. But you can see that as it's running, those individual inputs kind of flicker and light up according to the states of each of the inputs. Now it's worth bearing in mind that the output you're hearing bears no direct relation to the input, so that flickering won't make sense according to what you can see. Now a very interesting feature of the buses is that we can change their orientation, and we do this by choosing a different bus mode, it's called, from the left hand side. That's these numbers over here on the left. Now it's confusing that these are numbered 1 to 8 because it's very easy to confuse them with the input buses themselves. They're entirely unrelated. It would be better, in my view, if these were given alphabetic names, 8, A, B, C, D, E and so on. But let's just see what happens when we click one of these. So we've got bus, we've got the input bus selected. If we click, let's say 3, those blue numbers move up to the 9 o'clock position, if you like, and significantly the bus lines are now travelling horizontally. So what you should immediately notice is they're connecting a different set of 8 cells, and the implications of this should become clear as we go. It does get kind of wacky, because if you choose one of the diagonal orientations, the numbers, by the way, over here relate to these numbers that appear just inside this outer blue ring. So if we choose 8, it'd be nice to imagine we could choose it by clicking on it there, which we can't. We just get this strange kind of isometric effect. What you'll notice now is the bus lines. Well, you might not notice it at all, which is one of the reasons I'm doing this video in the first place. It's not at all obvious until it's pointed out. Those lines now run through the grid on a 45-degree angle. Now it's very unclear, unless it's pointed out, which cells they're actually connecting. A diagonal bus always links 8 cells, still at 8 cells, along a 45-degree line. But let's take bus 1 as an example here. That basically only seems to cut through one cell. So what happens is it drops off the edge of the grid and then wraps around and connects another line of cells until it gets to 8 cells. So that's pretty wacky, but once it's pointed out, it's fairly clear. I did suggest to Igor that calling these bus modes wasn't the most clear description. Bus orientation might be a better label for these, or even bus route, which I thought was quite funny. So back to the plot. Well, now we're looking at how sounds get recorded into the grid, and so now we can see where the sounds come from. But of course that's only half the story. We need to see what determines when a sound and how a sound snippet actually gets recorded. And for that we need to look at the trigger buses, which are denoted by these red circles around the outside, currently in the 9 o'clock position. Now everything about the trigger buses works just like we saw for the input buses. If we go to the Trig tab at the top of the screen, we now see the property page for one of the trigger buses. Again, we have to select the specific bus along the bottom, and as you can see, they're all set differently. Now the most important things on this page are the 2 sliders to the left hand side. The first ties this trigger to a particular input. Now this, I think what you find is when you apply the default preset, I'm not sure about this, but it's usually initialized to the same input number as the trigger bus. So trigger 1 will have input 1 selected, trigger 2 will have input 2 selected, and so on. You change it by changing this slider, and unhelpfully it changes the value from, it kind of looks like 15, 14, 13. It's actually saying I3, I4, I5. But it can be connected to any input, and the trigger is considered active when the signal on that particular input bus exceeds a particular threshold, and that threshold is set, or we can tweak that with this second slider, the one labelled sensitive. In fact, there's a kind of a meter alongside that, and this is the bus is like the trigger is like a gate, so it's on or off, open or closed, and it's basically open or on or active when that meter tops out. And you can see if we change that slider, it's obviously a very loud bus. We're affecting that. There is a way we can hear that. This is the way I said earlier. There's a way to preview an input bus. You have to do it obliquely by coming to the trigger page for a trigger that's monitoring that bus, and we do it by clicking the test button. Of course I'm muted so we won't hear it. So that particular input bus is playing we just go back to it, a thing called drums.aif, so it's a drum sound. It sounds like while I'm here, I'll just draw attention to the, I mean, we can go, we'll get carried away here and point out everything as we pass, but you can actually tweak that trigger with a bandpass filter, which is what the next two sliders are for, and that allows you to just get more fine control over how it triggers from the particular input signal. I'm not going to go into that and demonstrate it. So if we go back to the main page, you should now understand that those red blobs flickering on and off are the trigger buses firing or going active momentarily, depending on the values of the input buses they're connected to. If we just quick look at that trigger page, you can see I've left this, I think, at a default. So trigger 3 is triggering on the input 3, trigger 4 is triggering on input 4, and so on. Let me just see. So trigger 5 is triggering intermittently. If we change that to be monitoring the same bus as input 1, they should flicker more or less in unison. So if we just do that, trigger 1 is monitoring input 1, trigger 5 is currently monitoring input 5. We change that to monitor input 1. We need the threshold to be about the same, so 3.94 units, whatever that is, minus 3.94. There you go. So we should see buses 1 and 5, triggers 1 and 5. Well, we're not seeing them fire in unison. What's going on there? The frequency sliders are set differently. So what are they set at? 6.7 something and 6.2 something. So now they should be in unison more or less, 1 and 5. Hopefully you can see they more or less are. Okay, that's another diversion. Right, so why are we telling you all this? Well, let me just set my input buses to be the 6 o'clock position. Now the interesting part is, whenever a trigger bus crosses an input bus, they cross over a particular cell, obviously. That cell will record a snippet from the input bus when both the trigger and the input are active at the same time. That's how things get recorded into the matrix cells. So you can immediately see the significance of changing the bus mode, i.e. the bus orientation, because changing the orientation of the input bus connects up a completely different set of 8 cells, and so those intersections are all in different places, and consequently introduces an entirely different set of recording possibilities. Now before moving on, I'll just point out that recording isn't quite so simple as I've described. In fact, whenever a trigger bus fires or goes active, in other words, it records something to the next empty cell on the trigger bus, and you can tell which cells are occupied because an occupied cell, or a cell with a recording in it, has a square outline around it. That's what all those squares are. Now whichever cell that is, there will always be an input bus passing through it, and so sound from that input bus is recorded if the bus happens to be active. Otherwise, silence is recorded. So in other words, even if the input bus that the trigger bus crosses isn't active, we still get something put in the cell. Now I'll leave it as an exercise to the viewer to think about why that's a useful thing to happen. The length of that recorded snippet, by the way, is set on the trigger page. We go back to there, and it's either a fixed value, which is over this slider over towards the right of center, and that's in beats, or, as is the case here, it's determined by how long the trigger remains active for, subject to a length limit of 8 beats. And 8 beats is the maximum length of a recorded cell snippet. Okay, so that's it for the first part of the puzzle, how sounds get recorded and stuffed into those cells on the grid. But how do sounds get played back? So all the while those trigger buses are doing their thing, sampling inputs and stuffing snippets into the matrix cells. Something else is continually sweeping through the matrix and harvesting, if you like, cells to be sent to the output. And this is the job of the sequencer, which has inevitably its own 8 buses, and those are denoted by the purple ring and blobs. I don't know if I've said this, but you can switch between the buses by clicking these little buttons at the bottom left of the screen, and that not only highlights them but allows you to click the bus mode buttons on the left to change the orientation. So the sequencer buses work just like the other buses, except for activation purposes they're treated as a whole rather than individually. If you go to the Seek tab, you'll see there's no individual bus numbers along the bottom. So we set everything in this one page for the sequencer. So activation is, generally speaking, in step with the BPM clock, and by default the buses cycle through each one individually every beat, which you can see at the main page here. But back on the Seek tab, we can change that with these buttons over here. We can change the direction so the sequence is backwards. Or we've got pendulum, which is ping pong, and there's a random mode. We can also, there's a divider, so we can slow down or speed up. That's as fast as we can go. One advanced thing we can do is we can unlink the sequencer from the BPM clock, so it's triggered by one of the inputs. So we do that with this slider here, second one along. It's set to I1 by default. We can change it. This is kind of like the trigger. In fact, it's almost exactly like the trigger works. And to make that active, we'd have to change this sensitivity slider from, I think, from off to a value. Yeah, so you see it's now stopped ticking in a clock-like fashion on the main page. I'm not going to say anything more about that for now. It works, as I say, just like the triggers. So let's go back to the main grid, and we'll see that the trigger is perpetually moving. Actually, that's a bit of a pain. You can't actually stop this. I've got it muted, but if I try and stop this by clicking the start button off, it doesn't stop. What it stops doing is inserting new things into the matrix, but there's a whole bunch of stuff already stored up there, and the clock is still ticking. So we have to wait until that all gets output in due course before we stop hearing anything, which is a pain, really. I think Igor has said he might introduce some tweak to that so you can shut it off in a future version. Now, if you remember back to how the trigger buses interacted with the input buses for recording, this is similar for output, but it's kind of backwards. So each time a given sequence bus activates, it passes through 8 different cells, so in this case sort of 8 vertical columns of cells, and of course it also crosses 8 different output buses, which are the green buses. If we put those at the 7 o'clock position for now, so they're, oops, that's the wrong, didn't mean to do that. The green ones, 7 o'clock position. The sequence is running vertically, the output buses are running horizontally. So for any of those output buses that are crossed by an active sequencer bus over a cell that contains a recording, so that's the one with the square outline around it, remember, the output bus is activated and the sound is played back. So of course this means that up to 8 different sounds could be played back simultaneously, although as we've seen, some of these might actually contain silence which is technically not a sound, I suppose. Now, you knew I was going to say this bit, but if you try this out, you'll find it's actually much more complicated than that. In particular, some cells seem to hang around a lot longer than you'd expect without getting played back. Now this is because there are several different attributes that a cell can have or be given that modify its persistence, shall we say. For example, in fact, let's look at that. If we go to the Control tab, there's a thing called, if you look at the two rightmost sliders, we've got skip and we've got repeat. Now skip and repeat both modify a cell's persistence. If it has skip, I think that means the cell won't be played until, well, this is a number, so if it's 5, it won't be played until, I suppose, the 5th time that cell encounters an active sequencer bus. I hope that makes sense. And likewise repeat, rather than being skipped, repeat will play the sound, but it won't empty it out of the cell. If it's got, interesting, that one's set to -4. If it's set to +4, it plays it 4 times before it's considered, the cell is considered empty. I think -4 means it plays it 4 times, but it plays the sound backwards, which is kind of useful. Incidentally, if you want to try this out, you'll notice that those cells with the white dot in the middle are the ones that have got the skip parameter set. Now, I'm saying those cells have got the skip parameter set, but just to make things even more complicated, that last part isn't actually about attributes that a cell itself can have. It's about attributes applied to every cell on a given control bus. And of course the control buses are the last ones that we haven't looked at, and they're denoted on this grid by these grey or perhaps olive green blobs. Now again, the control buses work just like the others in terms of orientation and hence of which particular 8 cells they link together, but there's no concept of activation. The control buses are considered active all the time. So that's pretty much where we need to be. Now the control and the output buses are where in case you're wondering, all the processing, the mangling gets done. In fact, there's 3 different tabs here. We've got control, which is the one we just sneaked a look at. So this has the skip and repeat parameters on. It also has some controls for tweaking the pitch of the sound. And in the middle we've got a bit mask thing. Now this bit mask thing is kind of reminiscent of the address masking function if you've got Fieldscaper or Soundscaper. The processing and you'll notice there isn't a bus called processing. Processing is actually part of the output bus. I guess just all the functions wouldn't fit onto one page. So processing, we've got all sorts of effects, decimation or decimator, ring mod, I suppose, overdrive, tremolo, amplitude mod, chorus, flanger, phaser. We've got a high pass, low pass or band pass filter or a notch filter. What else? Rate and feed, that's probably a delay. On the output tab we can change the pan, we can change, it's got EQ settings. So anyway, all of those things can be set from there to do the actual sound mangling. But really the purpose of this demo is to just illustrate or at least outline how the settings of this front matrix screen and particularly the interactions of the settings of the what are called bus modes create just endless possibilities for how all of these things interact in the writing of or the recording of sound into the cells, and then in the extraction of sound from the cells to be played back, and indeed in the mangling that's done prior to that playback. And I guess it goes without saying that for an app by Igor, all of these parameters can be, almost without exception, be automated. And these automations are, by and large, they're kind of LFOs essentially. So if we just choose one that random, well not random, but this one here is automated, and this is a bit like the user interface on both Synthscaper and Classic FX. The base selected value is the orange triangle. The varying modified parameter is the green triangle. This one here is moving as well. And if we actually click on the button, the auto button, it takes us into a new screen to tweak in great detail that particular automation. And you can change that LFO rate. We can change it from a sine wave to a different kind of wave, etc. You know, and we've got that for every parameter. So knock yourself out. So I think that's all I'm going to say about BeatCutter for now. Once you understand the matrix and the bus system, everything else is fairly conventional, as you will have seen with the effects, the audio effects and the automation and so on. Like all of Igor's apps, it's absolutely crammed with tweakable things, although these are distributed across many different pages and aren't always, it has to be said, organised in ways that are intuitively obvious. But it's just amazingly well thought out and features what I consider to be an ingenious visual graphical display of how the different inputs and outputs and processing interact. But this is one of Igor's trademarks, finding novel ways to present complex information succinctly. I mean, his interfaces for Synthscaper and classic effects are amazing. And in this case, it seems to me that having a grasp of the bus architecture and of how the buses interact helps generate intuitions for using the app effectively.